Article 210.84 in the National Electrical Code does not specify a limit on the number of receptacles that can be protected by a single ground fault circuit interrupter device. However, an informational note in the National Electrical Code Article 210.8 states that it is typical practice to limit the number of receptacles protected by a single 20-amp ground fault circuit interrupter to 2. This is because the National Electrical Manufacturers Association recommends that a 20-amp ground fault circuit interrupter device be used to protect a load of 16 amps or less. Therefore, it is considered good practice to limit the number of receptacles protected by a 20-amp ground fault circuit interrupter to 2. It is important to note that this is only a recommendation and not a code requirement. The actual number of receptacles that can be protected by a ground fault circuit interrupter device will depend on the load and the specific device being used. Understanding the nuances of ground fault circuit interrupter protection involves knowing the difference between what the National Electrical Code mandates and what constitutes a recommended or best practice. While the code itself provides the rules that must be followed to ensure electrical safety, industry standards and expert recommendations often offer further guidance for optimal performance and safety. In the case of ground fault circuit interrupters, specifically 20-amp units, there is a common recommendation to limit the number of receptacles they protect to 2. This recommendation stems from the National Electrical Manufacturers Association and is based on ensuring that the load connected to the ground fault circuit interrupter does not exceed a certain threshold. The National Electrical Manufacturers Association advises that a 20-amp ground fault circuit interrupter should ideally protect a load of 16 amps or less. This is to provide a safety margin and prevent the ground fault circuit interrupter from being overloaded, which could lead to nuisance tripping or, in more severe cases, failure of the device. To determine the appropriate number of receptacles to connect to a ground fault circuit interrupter, it is essential to consider the anticipated load of each receptacle. This requires an understanding of the types of devices that will be plugged into the receptacles and their corresponding amperage draw. For example, if the receptacles are likely to be used for high-power appliances or tools, the total load could quickly exceed the recommended limit for a single 20-amp ground fault circuit interrupter. In such cases, it would be necessary to either reduce the number of receptacles connected to the ground fault circuit interrupter or install multiple ground fault circuit interrupters to distribute the load. Conversely, if the receptacles are only used for low-power devices such as lamps or phone chargers, it may be possible to connect more than 2 receptacles to a single 20-amp ground fault circuit interrupter without exceeding the recommended load limit. However, it is always prudent to err on the side of caution and avoid overloading the ground fault circuit interrupter. It is also worth noting that the type of ground fault circuit interrupter can also affect the number of receptacles that can be safely connected. Some ground fault circuit interrupters are designed to handle higher loads than others, and it is important to select a ground fault circuit interrupter that is appropriate for the intended application. In addition to the load considerations, there are also practical reasons for limiting the number of receptacles connected to a single ground fault circuit interrupter. If a fault occurs on one of the receptacles, the ground fault circuit interrupter will trip, cutting off power to all of the receptacles connected to it. This can be inconvenient if the other receptacles are being used for critical equipment or appliances. By limiting the number of receptacles connected to each ground fault circuit interrupter, the impact of a fault can be minimized. Furthermore, troubleshooting electrical problems can be easier when fewer devices are on a single circuit. When a ground fault circuit interrupter trips, isolating the cause is simpler if there are fewer potential sources of the problem. This can save time and effort in identifying and resolving the issue. While the National Electrical Code does not explicitly state a maximum number of receptacles per ground fault circuit interrupter, it is important to consider the broader context of the code and its intent. The primary goal of the National Electrical Code is to ensure electrical safety and protect people and property from electrical hazards. Therefore, even in the absence of a specific rule, it is important to follow best practices and recommendations that promote safety. In the case of ground fault circuit interrupters, the recommendation to limit the number of receptacles to 2 per 20 amp unit is a prudent measure that can help to prevent overloads, minimize the impact of faults, and simplify troubleshooting. Moreover, local codes and regulations may impose additional requirements or restrictions on the number of receptacles per ground fault circuit interrupter. It is essential to check with the local electrical inspector or building department to ensure compliance with all applicable codes and regulations. These local rules can vary depending on the jurisdiction and may be more stringent than the National Electrical Code in some cases. When installing or modifying electrical circuits, it is always advisable to consult with a qualified electrician. A qualified electrician has the knowledge and experience to assess the load requirements, select the appropriate ground fault circuit interrupters, and ensure that the installation complies with all applicable codes and regulations. They can also provide valuable advice on how to optimize the electrical system for safety and efficiency. Ground fault circuit interrupters are a critical safety device that can help to prevent electrical shocks and electrocution. They work by monitoring the current flowing through a circuit and detecting any imbalances that could indicate a ground fault. A ground fault occurs when current leaks from a circuit to ground, which can happen when a person comes into contact with a live wire. When a ground fault circuit interrupter detects a ground fault, it quickly trips the circuit, cutting off power and preventing injury. Ground fault circuit interrupters are typically required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code specifies the locations where ground fault circuit interrupter protection is mandatory, and it is important to comply with these requirements to ensure safety. There are two main types of ground fault circuit interrupters: receptacles and circuit breakers. Ground fault circuit interrupter receptacles are installed in place of standard electrical receptacles and provide ground fault circuit interrupter protection at the specific location. Ground fault circuit interrupter circuit breakers are installed in the electrical panel and provide ground fault circuit interrupter protection for the entire circuit. Both types of ground fault circuit interrupters provide the same level of protection, but they are used in different applications. Ground fault circuit interrupter receptacles are typically used in locations where only a few receptacles need ground fault circuit interrupter protection, while ground fault circuit interrupter circuit breakers are used when an entire circuit needs to be protected. When selecting a ground fault circuit interrupter, it is important to choose one that is rated for the voltage and amperage of the circuit. The ground fault circuit interrupter must also be listed by a recognized testing laboratory such as Underwriters Laboratories to ensure that it meets safety standards. In addition to ground fault circuit interrupters, there are other types of safety devices that can help to prevent electrical hazards. These include arc fault circuit interrupters, which protect against fires caused by arcing faults, and surge protectors, which protect against damage from voltage surges. Arc fault circuit interrupters are typically required in bedrooms and other living areas, while surge protectors are recommended for protecting sensitive electronic equipment. Maintaining ground fault circuit interrupters is essential to ensure their proper functioning. Ground fault circuit interrupters should be tested regularly to verify that they are tripping correctly. This can be done by pressing the test button on the ground fault circuit interrupter, which should cause it to trip. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. Ground fault circuit interrupters can also be damaged by power surges or other electrical events. If a ground fault circuit interrupter has been exposed to a power surge, it should be tested to ensure that it is still functioning properly. Replacing a ground fault circuit interrupter is a relatively simple task, but it should be done by a qualified electrician to ensure that it is installed correctly. The electrician will also be able to inspect the wiring and ensure that there are no other electrical hazards. In conclusion, while the National Electrical Code does not specify a limit on the number of receptacles that can be protected by a single ground fault circuit interrupter device, it is considered good practice to limit the number of receptacles protected by a 20-amp ground fault circuit interrupter to 2. This recommendation is based on ensuring that the load connected to the ground fault circuit interrupter does not exceed a certain threshold and preventing overloads, minimizing the impact of faults, and simplifying troubleshooting. It is also important to comply with all applicable codes and regulations and consult with a qualified electrician when installing or modifying electrical circuits. By following these guidelines, you can help to ensure electrical safety and protect people and property from electrical hazards. The application of ground fault circuit interrupters has expanded over the years, and the National Electrical Code has been updated accordingly to reflect these changes. For example, ground fault circuit interrupter protection is now required for most outdoor receptacles, as well as receptacles in garages and unfinished basements. These requirements are intended to protect people from electric shock hazards when using electrical equipment in damp or wet locations. The technology behind ground fault circuit interrupters has also advanced, with newer models offering improved performance and reliability. Some ground fault circuit interrupters now feature self-testing capabilities, which automatically test the device on a regular basis to ensure that it is functioning properly. These self-testing ground fault circuit interrupters can provide added peace of mind, as they can detect problems that might otherwise go unnoticed. In addition to the traditional ground fault circuit interrupters, there are also portable ground fault circuit interrupters that can be used to protect electrical equipment in temporary locations. These portable ground fault circuit interrupters are often used on construction sites or at outdoor events where there is a risk of electric shock. They typically plug into a standard electrical receptacle and provide ground fault circuit interrupter protection for any equipment that is plugged into the portable ground fault circuit interrupter. When using a portable ground fault circuit interrupter, it is important to ensure that it is properly grounded. This can be done by connecting the grounding wire of the portable ground fault circuit interrupter to a known ground source, such as a metal water pipe or a grounding rod. Proper grounding is essential for the ground fault circuit interrupter to function correctly and provide protection against electric shock. The cost of ground fault circuit interrupters has decreased over the years, making them more accessible to homeowners and businesses. This has led to increased adoption of ground fault circuit interrupter protection and a reduction in the number of electrical shock injuries. While ground fault circuit interrupters are an effective safety device, they are not foolproof. They can be damaged by power surges, lightning strikes, or other electrical events. It is important to inspect ground fault circuit interrupters regularly for any signs of damage and replace them if necessary. Ground fault circuit interrupters are also not designed to protect against all types of electrical hazards. They are primarily intended to protect against ground faults, which occur when current leaks from a circuit to ground. Ground fault circuit interrupters will not protect against shocks from line-to-line contact, which can occur when a person comes into contact with two live wires. To protect against line-to-line contact, it is important to use other safety measures, such as wearing insulated gloves and using insulated tools. In addition to ground fault circuit interrupters, there are other types of safety devices that can help to prevent electrical hazards. These include arc fault circuit interrupters, which protect against fires caused by arcing faults, and surge protectors, which protect against damage from voltage surges. Arc fault circuit interrupters are typically required in bedrooms and other living areas, while surge protectors are recommended for protecting sensitive electronic equipment. The National Electrical Code is constantly evolving to keep pace with changes in technology and safety standards. It is important to stay up to date on the latest code requirements to ensure that your electrical system is safe and compliant. The National Fire Protection Association, which publishes the National Electrical Code, offers a variety of resources to help people understand the code and its requirements. These resources include training courses, publications, and online tools. Consulting with a qualified electrician is also a good way to stay informed about the latest code requirements and ensure that your electrical system is safe. A qualified electrician can assess your electrical needs, recommend the appropriate safety devices, and ensure that your electrical system is installed and maintained in accordance with the National Electrical Code. By taking these steps, you can help to protect yourself and your family from electrical hazards and ensure that your electrical system is safe and reliable. Remember that electrical safety is an ongoing process, and it is important to be vigilant and take precautions to prevent electrical accidents. Always follow safe electrical practices, and never attempt to repair or modify electrical equipment unless you are qualified to do so. If you have any questions or concerns about electrical safety, consult with a qualified electrician.